All right, taking a look at our opener here to 6.5. I'm sorry, 6.6. Says, are the following two triangles similar? If so, write your similarity statement. So looking what's here, we've talked about your shortcuts. Right now, we know no measurements of our sides, so our only option is for angle, which means I need two angles from each triangle to be congruent. If you notice, both the small triangle and the big triangle, they share angle C. So we can say angle C is congruent to angle C, and that was our reflexive property. Now, our other set comes from the set of parallel lines that we have here. When these lines are parallel to each other, remember your corresponding angles will have to be equal. So angle CBE will be congruent to angle CAD. And our reason is they are corresponding angles. So are they similar to each other? Yes, they are. As to why, we have two sets of angles being congruent. So to write our similarity statement then, it is triangle CBE is similar to triangle CAD. Now, when you have these lines being parallel, there's other things that are going to happen. Right? And the first one we're going to talk about is how when these lines are parallel, it's going to break these sides up proportionally. Meaning, maybe if this is 2 and this is 6, if this is 3, to find x, those sides have to be proportional. So when I compare the 2 to the 3, for example, it would have to be the same as comparing the 6 to the x. Or if I compare the 2 to the 6, it's going to be the same as comparing my 3 to my x. Right? Any of those will work out just fine. And then you'll be able to cross multiply and find those pieces. And that's what our first theorem here says. If a line parallel to one side of the triangle intersects the other two sides, then it divides those two sides proportionally. Right? So we are looking at a picture that looks just like this. So these ratios would have to be the same. That ratio of 1 to 2 will be equal to 3 to 6. Or if I want to compare 2 to 6, then I'm comparing 1 to 3. Right? Those sides are going to get broken up proportionally. Likewise, we will have a converse to it here. Right? So all we're looking at is if TU is parallel to QS, then that ratio of RT, which is 6 over 2, will be equal to RU, which is 3. RU. Let's see here. 6 over 2, which is equal to RU, which is 3 over US, which is 1. Right, now, as I was saying, the converse will be true also. We can tell if these lines are going to be parallel or not based on whether their sides are proportional. If a line divides the two sides of a triangle proportionally, then it will be parallel to those two sides. So let's take a look at our first two problems here. The first one says, in your diagram, yes, these two lines are parallel. And RQ is 10, RS is 12, ST is 6. Says find the length of QU. If the lines are parallel, then these sides are going to be proportional. So if I compare 12 to 6, that will have to be the same as comparing 10 to x. Then I'll be able to cross multiply. Get 12x equals 60. Divide by 12 and we get x to equal 5. Now the next problem that's there, it says a spoiler for a remote control car is shown where AB is 31, BC is 19, CD is 27, and DE is 23. It says explain why BD is not going to be parallel to AE. I'm going to redraw this just so we can look at it straight on. Now, when we label our pieces here, it says not DE, sorry, DB. They say AB is 31, BC is 19, CD is 27, and DE is 23. So in order for these lines to be parallel, these ratios have to be the same. 19 over 31, 27 over 23. Those two ratios are not equal, so that is why they are not parallel. Now, if I look at my triangle then, what we're looking at here is those ratios being the same. I can do A over E, then I have to do C over F. If I wanted to do A over C, that's fine. Then I have to do E over F. Right? The key is to be consistent. I can even extend that further if I wanted to. I could do I could do A plus E over B. Then I'd have to do C plus F over D. The key is you need a beginning and a stopping point. When I come here, I cannot look at A plus B because A doesn't have a beginning part to it. We don't know how far out that segment goes. Notice in that previous slide, they all met at this point up here. There was no open-ended piece, right? So I cannot use A. I cannot use E. I cannot use D, and I cannot use H. Right? Likewise here, I can use any set as long as it's inside of this top line and inside of this bottom line. Right? I cannot use the M and the N. I cannot use anything that would come down here. I have to stay in between those parallel lines. Right, and that's the idea here in Theorem 6.6. If three parallel lines, or you could have 4 or 5 or 6, intersect two transversals, then they divide those transversals proportionally. Right? Really looking at these pieces in here. If this is 2 to 3, if this is 4, then this is going to have to be 6. Right? Those ratios have to be the same. That's what that term proportionally means. Notice once again, we're not coming out here or out here. We are looking at these segments between your parallel lines. That's what we have to work with. Right? Now, the other one we're going to look at here, when you have an angle bisector, it is going to break apart that triangle proportionally as well. Meaning that ratio of x to y is going to be equal to the ratio of A to B. Or if you want to compare x to A, then we have to compare y to B. Right? And that's what my last theorem here is going to say today. If a ray bisects the angle of the triangle, then it divides the opposite side into segments. So my angle bisector comes through, it divides the opposite side into segments whose lengths are proportional. So this is 1 to 2. Maybe if I make this 3, then this one here is going to have to be 6 because they have to be proportional. That ratio of AD over BD has to be equal to that ratio of CA over CB. So the ratio of these two sides has to be the same as the ratio of the remaining two sides of your triangle. Now we're going to use each of these theorems that we just went over for one of the examples coming up. In example 3, it says a farmer's land is divided by a newly constructed interstate. The distances shown are in meters. Find the distance CA between the north border and the south border of the farmer's land. So when I'm looking at my figure here, here's my borders. Notice all my lines coming through are parallel. So those segments have to be proportional. That ratio of 2,500 to 3,000 will have to be equal to 2,000 over whatever this bottom part is here. We'll just call it x. Right? So now we cross multiply. 2,500 times x is exactly that, 2,500x. 3,000 times 2,000 gives me 6 million. And then we're just going to divide by 2,500 on each side. We get x to equal 2,400. Now, please keep in mind, this x is just for this bottom piece. They want the distance from the bottom to the top, from the north border to the south border. So I need to add those together to get my total distance of 4,400 meters for our answer. Brings us to our last example today. Now we're looking at that angle bisector theorem. Since these two angles are equal, what my theorem says is the ratio of DG to FG will be the same as our ratio of ED to EF. So that ratio of X to, in this case, for G to F, if the left part is X, the right part has to be 14 minus X. Equals on the right-hand side, we get 8 over 12. So when we cross multiply here, 12 times X is 12X. 8 times 14 minus X, we get 112 minus 8X. So we'll add our 8X to both sides. So 20X equals 112. And then we'll divide by 20. We get X to equal 5.6. That means that X is 5.6, which is DG, which is exactly what they asked for. Right. Which brings you to your homework here tonight. Please note the Chapter 6 test, we're not going to talk about that being on Thursday. We'll talk about the actual date for it here when we get into class. All right, but your homework here is pages 400 to 401, numbers 3 to 18.